All right, so this section is on different units of measures. Some of it's about converting, well, really, I guess all of it is about converting. Now, you should not expect to need to be able to convert things like centimeters to feet or anything like that, because, of course, feet is not a standard unit of measure. That's the American unit of measure. So that's just kind of a little side note there. So the International Units of Measure, or SI, Système International, was a system of measurement that was developed in France around the time of the revolutions in the 1790s. It's used worldwide because the calculations and conversions are easier than other systems. I don't know about you, but I know when I was in elementary school, I can remember kind of being led to believe that any moment we were going to be switching to the metric system in the United States. And I can remember my father-in-law saying the same thing. Of course, hasn't happened, but we are not the only one that uses non-metric systems. Liberia and Myanmar also use that. So there are 7 base units. So those are as listed there. You've got length, mass, time, electric current, temperature, amount of a substance, and intensity of light. And those base unit names in the SI unit and their symbols as well. Now, to change those into different units, to make them smaller, to make them larger, we can use prefixes. Now, of course, you're not going to use that on things like seconds and even kelvins and that kind of thing. This is going to be more for things like the meter and the gram. So we're going to pretty much in here deal with the meter, dealing with meters as far as doing the different prefixes. So you can see those prefixes there. Some of those were new to me. You've got tera, giga, mega, kilo, hecto, deci, or deca, deci, centi, milli, micro, and nano, and their abbreviations. Now, I can't really see anything about as far as what you're going to have to know, for, like memorize for these. So as we go through and do our review, we'll talk for the exam, we'll talk more about that. This is not in your formula booklet, so when we do the review, I'll have some better answers for you about what you would have to kind of memorize. Now, some non-SI units in terms of SI units. Time, of course, you can measure in minutes, hours, and days. But up above here, it said that my SI unit for time was seconds. So a minute, of course, is the same thing as 60 seconds. An hour is the same as 60 minutes or 3,600 seconds. And a day is 86,400 seconds. If you haven't noticed yet, for the international numbers, they don't use commas. So the 86,000 there, they just leave a little space for that instead of putting a comma. The hectare, that's a unit like we use acres. That's the unit though that other nations are using. And then volume, of course, liters. And then mass, which that's a new one for me. Tone, I'm guessing. I'm not even really for sure. And then we've got 3 temperature scales: Fahrenheit, Celsius, and Kelvin. You can see the differences there in those scales. Of course, we use Fahrenheit here. There are other countries, the Bahamas, I think, Cayman Islands, a few others. It's not just us. Now, I will tell you that the only one that is in our book is that table right there. They don't talk about temperature and time and that kind of thing, but I've seen that in other books. So I just want to kind of throw that out there that maybe these would be things you would need to know as well. Okay. Now, if we want to convert from one SI unit to measure to another, we're going to multiply or divide by an appropriate power of 10. Now, your book goes about it a little bit differently. They talk about dividing by really by the powers of 10, but by the powers of 10 that they have listed in the table here. So, for example, we're getting ready here to do, to find my problem here, we are doing kilometers to centimeters. So you would have to know that kilometers is a 10 to the third, and that a centimeters is 10 to the negative 2, and then you end up dividing those measures. I think that's a little bit harder. So I would look at it, I think well, if you have this little diagram here, we're going from kilometers to centimeters. So to go from kilometers to centimeters, of course, with the picture, this is pretty easy. I'm going to go 1, 2, 3, 4, 5 to the right. So that's going to be 10 to the 5th power. So we would take our 34 kilometers times 10 to the 5th, and that's going to give me a lot of centimeters. Now, what I would do personally, I'm not going to remember that it's 5 spots from kilometers to centimeters, so I would convert my kilometers to meters. So I think it's pretty well known that there are 1,000 meters in a kilometer. So if I have 34 kilometers, that's going to be 34,000 meters. I also think it's pretty common knowledge that there are 100 centimeters in a meter. So if I take my meters now times 100, I get that same answer. I don't care how you do it, but I think that's going to be the easiest way of going about it. Now we go in the opposite direction. I'm going to go from a milliliter to a liter. So in the case of my table here, we don't have, well, yeah, I guess these are my milliliters. I was thinking it wasn't in the table. Here's my milliliters right there. So we're going to go from a milliliter to a liter. Now that would be my SI unit. Pick the bad color here. That would be my SI unit. So we're going to go 1, 2, 3 spots to the left. So we could go about it that way. We would divide because we're going to the left. Or, again, I think it's pretty common knowledge that there are 1,000 milliliters in a liter. So we're going to take our 1570 divided by 1,000, and we get 1.57 liters. Or, like I said, we could take our 1570, divide it by our 10 to the 3rd, because we went 3 places to the left, and you get the same answer. Now, if you're doing a conversion for an area or a volume, you need to think about converting each part of that unit. For example, if you're converting a meters cubed to a centimeters cubed, you have to convert every meter to centimeters. So a meter to a centimeter is just times 100, but if I'm going to do a meter cubed, I'm going to have to do 100 cubed. So, for example, we have a field that is 91.4 meters by 68.5 meters. So find the area of the field in meters squared. No big deal. Length times width, 60.9 meters squared. Okay, now calculate that area in centimeters squared. Now, of course, you could multiply the, or convert the meters of the dimensions into centimeters, but what if they just gave you the area and you didn't have the individual dimensions? Then you would have to know how to do it this way. So to convert a meter to a centimeter, I'm going to multiply by 100. But since I'm doing area, that's going to be 100 squared. So 6260.9 times 100 squared. That's going to give me 62,609, 62 million centimeters squared. Now that would very much, or very likely be something they might ask you to do in scientific notation. This unit here about the conversions is very likely to be in a longer question where they're asking you to do a variety of things. Okay. Last couple here. The speed of sound in air is given by 300 meters per second. Okay, and actually this didn't come out so well. Meters per second to the -1 power. Now, think about writing that. Okay, a -1 power is the same as dividing, or dividing instead of doing a negative exponent, and so that's read in English as meters per second. So how many meters does sound travel in 1 hour? Okay, well, there are, of course, 60 seconds in a minute and 60 minutes in an hour. So there are 60 times 60, or 3,600 seconds in an hour. So we know how many meters we're doing in 1 second. So now let's multiply that times 3,600 seconds. So 300 times 3,600 would give me 1,080,000 meters. Okay. All right. Next, the SI unit for force is the Newton. If force is equal to mass times acceleration, excuse me, where force is the object, the force on an object, m is the object's mass in kilograms, and a is the acceleration of the object in meters per second squared. Find the units of a Newton in terms of kilogram, meters, and seconds. Well, this question seems harder than what it actually is. They really just, instead of writing meters times acceleration, they want you to actually put in those units. So mass was mass was kilograms. And my acceleration is meters per second squared. So we multiply that together, and that's going to be kilograms meters per second squared. Now, what they do so that it doesn't look like kgms is they kind of leave a little bit of a space in between all those units so that you can see that it's kilograms, meters, and then seconds squared, or per second squared. Okay. All right, the last one here, and I will have to apologize, these last couple of examples are examples from your book, but I couldn't really find examples similar to this, and there were ones in your homework that were like this, so I wanted to make sure that I had talked you through these, because I'm not sure that you're actually looking at the pages in the book. So just wanted you to be prepared here. The density of an object, and that kind of funny looking P there is a Greek letter rho, it's the lowercase letter. Is equal to the mass of an object divided by the volume of the object. If the dimensions of a 1 kilogram cube of metal are 10 centimeters on each side, find the density of the cube in kilograms per meter cubed. Okay, so I need kilograms and meters cubed. Well, I have kilograms and centimeters, and my centimeters aren't cubed. So first, let's change our centimeter into meters. So again, there are 100 centimeters in a meter. So I'm going to, in this case, since I'm going in the opposite direction, I don't want to end up with more meters. I don't want to end up with a bigger unit. I'm going to end up with a smaller unit. We're going to a larger unit, which means I'll have fewer of them, is what I mean to say there. That was kind of confusing. 10 divided by 100 is going to give me 0.1 meters. And a lot of times, you know, you can kind of use common sense. If you take 10 times 100, obviously that's going to be way too many meters for only 10 centimeters, so it's going to be dividing instead. Okay, so if this is a cube, then we want to find the volume. It's going to be the same on each side, so 0.1 to the third power, which is 0.001 meters cubed. Now, of course, we could have found the volume in centimeters and then converted it, but I think in this case this was easier. To find my density now, my mass is 1 kilogram, and my volume is 0.001 meters to the third power, meters cubed. So if I divide my numbers now, 1 and 0.001, that's going to give me 1,000 kilograms meters to the -3. So that means kilograms per cubic meter, if you want to say it that way. Would it be okay to write it like this? I don't see why not. It just would look weird. I guess not so much to us, but internationally it would look weird. Really, either answer there would be okay. Okay. Now again, any questions you have, let me know. I've not worked through all these problems, so there might be some that are harder than what I anticipated. Look at the answers there, but ask me. Like I said, they do their conversions a little bit different, so if you want to know if your way is okay, probably if you're getting the same answer, my guess would be yes. But if you're not sure, as always, let me know.